I'm honored now to introduce our next speaker, who goes by the simple moniker Moon Man. Any of you have guessed him? I'm sure some of you have. None other than our own Padma Shri, Dr. Mylswamy Annadurai. He is a renowned Indian scientist working as the Vice President for Tamil Nadu State Council for Science and Technology, and has held a number of posts with the Indian Space Research Organization, ISRO, including directorship of UR Rao's satellite. During his 36 years of service at ISRO, he had some major contributions, including two major missions of ISRO, Chandrayaan-1 and Mangalyaan. He will deliver an address on manufacturing industries, challenges and opportunities, and share insights from historic achievements that make us all proud. Ladies and gentlemen, I give you Padma Shri Dr. Mylswamy Annadurai.
Good afternoon to all. It's really a tall order challenge. Post lunch, second lecture, that too with all the modes you are planning to go to Costa Rica with your family, with the investment. Next 45 minutes, basically I'm trying to touch upon the topic manufacturing industries, challenges and opportunities. That in the process of while discussing, probably that green manufacturing also will come, because rocket science, where is the green manufacturing question will be there. I think probably I will touch upon, especially considering this podium. This is, I think, third occasion I am a part of IRM's thing, and some of you probably would have again be a part of that. Now, when I'm putting it here, basically the challenges may look like very big, but that big challenges also gives a very good big opportunities. Problem may look big, but the problem may be hiding a big opportunity. I think just as a part of a case study, I am trying to put it upon with my own experience over the last 40 years. This is just cut short and come to the point. This was a problem for ISRO in late 90s when the IT boom was coming up. ISRO also, Indian space program also coming up, and it caught up initial testing points and was entering into operational era. So ISRO needs to make operational launches and to make the satellites which are becoming part and parcel of various aspects of development aspects of the country. When that's happening, ISRO had a difficulty of retaining the people within the organization, and ISRO had a difficulty of recruiting the good talents. So this is really a big problem. How this big problem we addressed, and again coming back, how this big problem gave us a very good opportunity to the world of science. I think this is what I'm trying to put the things together. Now, the problem was how to retain the people. The problem was how to get the talented people into the ISRO in numbers. The answer came for that problem. The solution is destination of moon is ISRO next big thing. May look like totally different thing, but how it connected? How it connected to make sure that retaining the people within ISRO and attracting good talents from outside ISRO. So this putting it here is not only philosophical word, and it has given a very clear mark of when it has to launch to take place. At that time, I think India was yet to make even PSLV its operational. In spite of that, I think if you make it like that, if it all goes well, if you are able to make it reality by 2008, I think we will be able to get the problem solved. I think this is how it's happened there, and this is how one of the technology oration, then chairman of ISRO, Dr. Kasturangan told, that came in the newspaper. The first time a media got a hold of India going to the moon, told about that. But fast forward, same 2008, though it is put 1999, Government of India Organization, Secretary of Space is telling about that. And same 2008, I think we could launch, October 2008, we could launch the mission to the moon along with the host of the scientific instruments. And not only that, though it was a 70th mission go to the moon, it happened to be a first ever mission to unambiguously look at the various resources of the moon and to unambiguously give a water map, not only presence of water, which are all the places plentiness of water is there. I think that's what Chandrayaan was discovered, and that's what wherever we are telling about the blue marks indicates where the presence of water molecules have been seen. And why previous occasions people have not seen, I think they landed a place and they are looking for water. Those places water was not there. But here we did land on the moon, we looked for the water throughout the moon lunar surfaces, and we have picked up the places where the presence of water was there. And you look at the places where the Apollo or lunar landing took place, none of the places we are seeing presence of water even today. That means their discovery also correct, but that is not complete. So Chandrayaan made it a complete discovery, and this in the beyond that, I think India's space program has come up that way, and the original problem of retaining the people within the organization definitely it happened. And not only that, a good number of talents started coming from outside to ISRO. This has happened for the original problem as solution is concerned, but it didn't stop there. Okay, it's opened up a totally different dimension. Now you look back, I think you would have heard even few days back, US again back to the moon in a big way. Okay, the ambitious projects have started there, and it is initial setback. I think they will set it correct and come back for an unmanned mission, go to the moon and come back. In the process, it will put back some few satellites and things like that. This is to take the man in a big way, not just Armstrong landed on the moon, you know, but he was staying only for a few hours on the surface of the moon. But now this time is to make a modest colony back to the moon. Thanks to discovery of water on the moon by Chandrayaan, this happened. Okay, from 2009 onwards, last 13 years of working together, and this mission is coming out. And it's a matter of time this will happen. It would happen by this time, 3-4 days back, the launch would have taken place, but it didn't happen, but it will happen there. But taking back, well, that means this is to qualify the bigger launch vehicle that will take tons of the payloads there. That means a huge number of people, supplies, many things can be taken to the moon, so that moon colony, so that people staying for a longer time because of presence of water on the moon. Where the water is there, that places people will go. Like how olden days human civilization started taking from the riverbeds. I think something similar parallelism is going to happen where Chandrayaan has discovered water on the moon. Not only that, it has opened up a very big way globally how spacefaring nations will work together to make a modest colony in the moon. A roadmap is already in a place. 2024 will happen like this. 26 will happen like this. That means build up a notional human landing system reference architecture. That means starting with things will happen there. Beyond that, there will be a self-sustaining activities, water being there, and how a cultivation can take place there, how you can have your own habitat there, things like that will happen, so that possibly you self-sustaining human colony be beyond Earth, an extended Earth, moon coming is very much feasible. This is making whatever initially told a problem of how to retain people within ISRO, how to attract the people to ISRO. It started from there, but whatever the discovery, whatever you have seen, which previous missions have not seen, that are shown to the world, moon also can be an extended planet for various reasons. Of course, there are 100 reasons listed why we have to go back to the moon. I am not talking about that, but this is talking about technologically things are getting ready such that extended Earth possibility in the moon it's going to happen. Beyond that, I think it's happening beyond that, from that place there, from there going to the Mars also being talked about, anyway, that we are not touching about here. So this is way up to the end of this decade. You have the build-up of colony, how it will take place, such that you will be having a routine travels. You are the logistics in there, supply chains happening there, so that you have a standalone colony coming on its own point of view for extended stays, I think it's talking about. And towards that, while the NASA talks about that, there is a taking over by Elon Musk, private company, that is coming as another Starship that will be able to take nearly 100 ton plus the payload itself, and its system is on its own. So that will able to go to the people to the moon, beyond even moon to Mars also. So these sort of activities in the area of planetary mission not only for the explorations, I think it is having its own reasons to go to the extended planet. I think this is happening there elsewhere. Now while this happening there, yes, fast forward, initially I told 1998, what then Chairman ISRO has told, destination of moon is ISRO next big thing. I think I modified it slightly, just to take the moon out and put the Mars in, okay, as simple as that, keeping everything same. It happened 12th September 2011 for various reasons internally. As a compelling reason, with some of our hardwares, whatever we have done, should not become waste. And how you can make it next level. ISRO initially to sustain on its own, to have its own survival, it has to retain the people and it has to attract the people there. Now, ISRO has to go out much better way. Commercially, ISRO has to set its own brand. Okay? And when that comes, I think we thought this is one of the mission which will make that happen. So for that, a simple thing is you take the moon out, put the Mars there, but change the time. Instead of 2008 it was put there, you make it 2013 + 14. Previously it was looking like Saturn 2008, but there is no uncertainty of 2013 or 14. 2013 you launch it there, you take 9 months to go there. So the 2014 you can make it real reality. And that is the connectivity we are putting in 2013 to 14. 12th September 2011, in a conference I put it there. Okay, when we put it there, many people laughed at, because from there to here, not even 18 months we are talking about. 18 months making a mission is something impossible, because elsewhere normally they will take 4 to 7 years. In spite of taking that much of time, even the so-called developed nations, it is none of the spacefaring nation could succeed in a first attempt. The earliest was 5th attempt by US, 9th attempt by Russia. China was yet to succeed that time. Japan was yet to succeed that time. That time we are ambitiously placing, within 18 months we will make a mission to this happen. People thought it is very, very ambitious, but if it clicks, definitely the brand of ISRO will come. It's a big way. I think we started that way, and definitely we have done that. How we have done? Using a very, very modest launch vehicle. PSLV is a very, very modest launch vehicle. Whatever the launch vehicle previously has shown, similar numbers. That means you take the weight, and one shot you can throw it towards the Mars, moon, wherever the planet is concerned. But such a thing is not possible theoretically with our PSLV mission. PSLV at the maximum it can take somewhere around 1 ton satellite mass, and that satellite mass can be put not more than 24,000 kilometers away from Earth. But we have to go a long way. So that's why you look at here the small circle, it indicates where PSLV can put. From that plate, you have to go to the Mars, which is very, very beyond its reach of that launch vehicle is concerned. But still, we wanted to do it, so that one way, even with the PSLV, we have our ingenious way of doing, even go to the Mars, where the people, even for which a very, very, very muscle power of launch vehicles, they failed many occasions, succeeded. Is it possible to succeed in the first attempt? So things putting together we have done. That means you launch it on the 2013 November, and gradually increase its orbit by satellite built in the fuel. And on fine time, particular time, you're looking back, Mars supposed to have been elsewhere. Mars is sitting somewhere when we were launching. But now slowly you look for a correct time. From there you throw it. Particular velocity, particular time, particular direction. You push it there. So from there, from Earth-centered orbit, it will go to the Sun-centered orbit. Okay, that means like Earth is moving around the Sun, Mars is moving around the Sun. Similarly, our own man-made Mangalyaan also will go around the Sun. While doing like that, when it's coming at this point, Mars, which is supposed to there, which is traveling nearly around 29 kilometers per second, that also should come here. 9 months of time, you must be able to go somewhere around 500 kilometers above that place. So this is the overall problem, a big problem. Okay, but that gave us a very good opportunity how you can simulate the whole thing in a very better way, because today's computer simulation enables, today's knowledge about planetary systems observations will allow us to adjust and make the things accurately. And you can run for a few hundreds of simulation really without going to the embarking for the mission. So that way we iterated thousands of simulations we have done. Okay, and just I will run one such simulation, and you will able to see it here. Yeah, this initial orbit what PSLV has given. From here, when it comes here, you give one small kick, goes next orbit, that is the simulation run happens. Okay, when that's happening, Mars also keep moving. A particular one orientation, you push it, it will go, it will leave from the Earth's gravity and will go around the sun. Okay, and you keep simulating that and trying to see. Now you look at here, around the sun, Earth is moving its own gravity, natural force, Mars is moving its own way, but now we know each one of the particles where it is there. Now Mangalyaan is moving. It has to go in a particular speed, particular direction without spending the fuel, because with the PSLV you cannot store that much fuel and put it there. So that means the whole calculation, whole simulation, whole thing looking for should happen in a way such that when after 9 months of this, okay, when it comes over here, you should go just above 500 kilometers above the Mars. Okay, when this is basically with so much of simulations we have done, and we arrived at the number. That numbers at that time, that particular way it has been pushed there, and accordingly, as we have done the simulation, you could come there. But at that point, automatically the satellite has to reduce its speed to some extent, such that it will be captured by the Mars. That means from Earth, thrown to go around the sun, then particular direction when it's coming over there, capture around the Mars. So when we did like that, India has become the first ever country to acquire that in the history of aerospace, to acquire this mission is concerned. So this has definitely, it has captured the people's mind. Yes, ISRO is capable of making these missions very, very reliably and very economically and make it success. I think that is the one, definitely ISRO's brand value has come in a big way. But that alone is not enough. Now, Prime Minister of India has seen, I think he was watching us when the success happening in our control center. Then I think something has gone in mind. Then he came back, and not only he came back, he called all the department heads, secretaries of states of the central as well as state government was called, and the problem was given to them. That means ISRO is capable of making satellite launch vehicles like this, and with the minuscule budget, and they are able to make it reliably successful also. Now, taking this into thing, what each one of the department looking for from the space, be it education, be it health, be it tourism, be it forestry, be it defense, I think each one of you think about what you expect from the space. Then you give the problem to the ISRO. Let them come out with the solution. Okay. Now you can look at how the problems is getting regenerating itself and come for a sustainable goals to reach for the government back again it's happening there. And accordingly, I think a lot of brainstorming sessions took place, and that calls for huge number of satellites to be realized. This is another problem. That means you look at here another problem why it's coming is this is to start with, yes, around that time frame we are trying to recruit the people. Afterwards, this being Government of India organization, there is a stagnation. Government of India policy, we cannot recruit additional people. Because of that, almost headcount wise remaining the same. But now, once the departments are coming for the new requirements, now we have to work more and more satellites. So exponentially the requirement of satellites increasing, retaining the manpower same, headcount same. People retirement they will go, but you can get the new recruits. Headcount more or less same, but number of missions have to go. The requirement has gone up drastically. This is another problem. Gives opportunity. That opportunity is nothing but we could make the best possible the infrastructure to make the satellites in numbers, simultaneously in numbers. Okay. When I joined, it was 4 years on satellite, very, very modest satellite. But today, satellites are much, much more than like your initial cell phone versus what is the smartphone you are giving. That's the difference. That time also one cell phone in your pocket, this time also one smartphone in your pocket. But that cell phone versus smartphone is totally different. Same, today's numbers, if you talk about this satellite, today's satellites are much, much power and all thing point of view different, but numbers also gone up. Okay? That means not 4 years on satellite, we have to make 4 weeks on satellite. That is a tall order requirement has come, as Prime Minister has posted. We have done it. 36 months, we made 30 state-of-the-art satellites. Okay? Infrastructure build up, make the your supply chain properly, have the design, configuration, things like that, launch vehicle coming there, end-to-end solutions were arrived at to make that satellites number. Originally, it's called spacecraft. That means craft means you have to craft it. But today you cannot craft it, you have to produce it, you have to manufacture it. Okay? I think that the whole thing has happened there, and we made it in a record number of satellites, and that is the one which it is not Chandrayaan, it's not Mangalyaan. Mylswamy Annadurai is maybe known outside from Mangalyaan or Chandrayaan, but it is basically as a heart of the heart. It is the sheer number of satellites which we made, which very, very qualitatively also improve the governance of India. Today we talk about very confident digital India. Okay, the connectivity is nothing but provided by this. Today we are somewhat reasonably comfortable, our people in the border, either in the air or in the sea or in the Himalayas. I think thanks to our own satellites. So today our weather forecast is much better than it was previously thanks to the satellites. So the state of the satellites went for remote sensing, communication, navigation, weather forecast, and beyond that missions like Chandrayaan, Mangalyaan. I think that's what happening there. So this also we have done reasonably well. Life is keep going. So one fine day I was given farewell from ISRO. Okay, after 36 years of stay there, and the farewell also went reasonably well. I think after that only I had an opportunity to work with IRIM. Okay, I came to here, I think 2019 also is a part of this session. Okay, this was slightly different, I cannot tell the problem, it's a different orientation. Yes, I was trying to address what I have done last 36 years, probably I have done like that. And there, another thing, opportunity came. I think like you, one of person was Mr. Purushottam Agarwal, the founder of chairman of Samata Group. He happened to be there. Okay, and we had our own discussion, and he took me his corporate office. We had a discussion, and with the discussion, it came out they have some green solutions for them theoretically available, and they come out with an enzymatic solution wherein from the banana fiber. That means nominally a fiber from the cotton, or artificial fibers available, silk fiber available, but this is from the banana stem. After banana being harvested, the stem itself is there, from there you can extract fiber. That fiber, without going for any chemical treatment, they have enzymatic plant that can be turned into a textileable yarn. Yes, technologically arrived at, but they could not move forward. Then I asked him why. Then as a part of the discussion he told, because we need a huge amount of fiber, but few metric tons per day, but that much amount, as of now, today, we don't have technology to do that. Then I told, why can't? We have gone to the moon, we have gone to the Mars, why can't we make this technology available? Why can't we do? Okay, he also told, let us do that. Okay. Then I think, but when we are doing, it is totally different. I would have done thousands of simulations to go to the moon or Mars, but this is something totally different. It calls for unlearn what all I have done, but I have to relearn something more. Okay, that's what happened there. That happened, turned up to something like this. They are looking for fiber which is not more than 1% in the weight of the stem. It is just 1%. But what is the remaining 99%? I think the real gold was sitting there. Okay, when we looked at that, when we are looking at here, it has a structure, it has a sap, center core. What really we can do when you are looking for that? I think we can get something much better even beyond this. Fiber will come, fiber product. Fiber we are able to get even free of cost, but provided we are able to address something else better that way. I think we have gone to the from the fundamentals. I think we came out with so many other products, but having done that, how to make it a volume? To make it from 1% of fiber to few metric tons you have to come. That means it not even 250 to 300 gram will come per tree. But you have to make few metric tons, thousands and thousands of trees you have to make use. When you are making use, you get some other product. That product also, you can value addition is possible. Then putting together, then really to make it totally different way you have to approach. Keeping Tamil Nadu as one concept, then I came out with an idea. So these are all the things you make it a cluster. That means these are all the places where the banana cultivation is happening in numbers. And centering around that, 50 kilometer around, we are able to do that. After banana being cultivated, harvesting done, you bring only the stem. Within few days of that, it has reached to the centralized place. This place, you take fiber, and remaining other value additions also you are able to get out of that. I think that way we made, if you are able to make the system, we have to make a system now. This is only concept. Concept system you have to arrive at. So in this cluster, we are able to do it. I think we can do. What we should do in the cluster is a system something like this, a virtually plant. I told Mars, concept remains same, but that simulation is different from this simulation, correct? Na? But road remains same. How we can go, road remains same. So this is how we have arrived at. That means only raw material comes. From there, you can get the 5 products yes come out of this. 5 products. No other place. That raw material is only one. 5 products. When it comes out, fiber you can get free of cost in few metric tons. Okay. This is the. I think you are all the leaders of the industry. You know what I am trying to tell that, and that's what they have done. That this means processing capacity of one machine suit you to arrive at. Okay. That should have 7,000 stems per day. 7,000 stems it should process. And that has to give the for the original requirement of fiber. But it gives additionally beyond 3 metric tons of raw fiber, it can give 23 metric tons of central core. That can be used for some additional values we can do. 30 metric tons of sculpture that can be used for the green gasoline, green ethanol type of thing it will come. It gives another thing, 1,75,000 liters of safe water. That is a green manure back to the earth. Okay, that is basically a product which possibly in the long run we can even, India is importing a good amount of chemical fertilizer. This is a natural way we will able to get this, and the land it comes. When we talk about this number into every plant should have 50 such machines. I am talking about one machine suit can go like this. Then what is that machine suit? Is this for one such thing. Okay, it has been realized. Though we talked about 2019, now it has been realized by a combination of academia and GenCrust together, fully funded by GenCrust. Government is not coming into picture, fully funded by them. And this is a one such suit. Like that, 50 such things you will make the whole thing done there. And already this is in Bosawal, the factory has come. Okay, and there the machines are being lined up there. So, and to do that, a startup also has come from the academia and institutions are concerned. Now, concept to commercial. I think this New Year day, I think it has come in the Financial Times also. They are GenCrust. How we are talking about green solution for the better tomorrow. When we are talking about, because it gives various things as I told here. The fiber itself, even cotton, 1 kg of cotton fiber to make nearly 30 to 40,000 liters of water it consumes. Okay, that means water consumption also it will go in the way of carbon. But this is not this. Otherwise, going a waste, it's becoming as a thing. And similarly, even ethanol production, many things I think also a part of the system. So this is what I told is from 2019 where I came into the podium to where we stand here. What has happened there? Okay. So now coming back to my the story of ISRO. ISRO started very modest way, 1960s, you know that, 70s, and that also initially it was a hand holding by USA or Russia, that was there. But slowly, as I told, we have graduated from our own satellites, but then somewhere 90s, something else happened, then a drastic change, after Chandrayaan, many things happened. Now today, we are basically giving launching satellites for many people. Nearly 350 satellites have been launched for the other countries, and a good number of satellites also we are making. So many things are happening right away is concerned. Now, beyond that, now what we are trying to tell is, we are bringing good number of countries who are not spacefaring today, and showing them how India over the years, Indian space program, how it developed for the development of the nation. Why can't you? I think indirectly we are trying to show that, showcasing what are the facilities we have, how we make the satellites, how we launch the satellite, how the satellites are being used. And these people go back to their country and they are slowly starting their own space program. And towards that, how 60s we are laying to our America or Russia, I think something similar is happening right away for India and these countries. Already it started happening there. And now our target, what is the space program we are targeting is coming to a point. This is the government of India's Make India concept itself, it has been put there. I am putting the capital as it is and putting Indian space sector 2020 to 24, how it's supposed to grow. I think a target has been given. Initially I told each one of the targets, how we met that each one of the targets I showed. Okay, similarly this is the target now. To meet the targets, what is to be done is happening there. And the bottom line is, every dollar spent in space industry translates to close to $50 in societal value. I think that is the number. Okay, it is not only the $50 million what we are talking about here, its multiplication factor is another huge number. This is going to be taken into consideration. I think that's what today's government of India is taking and trying to pushing the people, and that's why the policy changes, many things are keep happening there. And while doing it, basically coming back to you here, it has basically on the 4 sectors, either manufacturing the satellite, manufacturing launch vehicle, or the launch service, or let everything be done there, satellite service, in terms of imaging, in terms of navigation, in terms of position fixing, in terms of communication, you name it. I think we can be many applications possible. Say this, any one of the 4 compartments, people can be part and parcel of it. Now almost the whole, all four are being open to private industry today. Okay, this is a huge amount of volume. Yes, as much as possible ISRO stretched, I showed that. ISRO stretched with own 18,000 manpower, what possible they have done, but that is not enough. Still we have to go for that. Nothing, I think it is not advisable to keep on stretching. I think you have to additional arms have to come back. That's why I think private industry has been pumped into that in this arena. While doing it here, there is another transition also taking place. You have to keep in mind. That means state-of-the-art satellites I told, previously bigger and bigger satellites we told. But now it is smaller and smaller, smarter satellites, and that number also keep increasing. You can see that exponentially that number is increasing. During the COVID itself, nearly 50,000 of the satellites which are launched for 60 years were launched in the last 3 years. That itself shows how much people are expecting in the space industry what to come there. Okay, Starlink is one such thing, OneWeb is another thing, many things are keep happening. So this is another trend in which we have to look for what's happening there. Yeah. Now that means previously the satellites were geosatellites, but whereas now we are talking about a very low Earth satellite, few thousands of number. That gives basically in the engineering term, one message if you go, return message to come at 240 milliseconds it takes. But here that means, but by the time you can have the 70 information possible with respect to the new concept. That means many activities, including your manufacturing industry connectivity point of view, doesn't mean IT engineer alone can be online, offline mode working. There is very good possibility 4G and 5G comes. Very many activities. I am working with another project with the practicing surgeons, how we can get connected for a surgery. Okay, surgery, because that means a super specialty hospital doctor get connected to a remote place, maybe in a border area, maybe Andaman, maybe northeast area, but someone has to be attended to at the earliest. So how it can be done? We are talking about that. When that being done, I think manufacturing, production industry also, many things possible to do that, provided this connectivity comes. That means, like a cell phone, the satellite is going to be part and parcel of our day-to-day life and day-to-day manufacturing, day-to-day, very many activities point of view, that's going to be a part and parcel of this. Yeah, this shows another statistics, how the whole group of activities happening there. That means the small launch vehicle, small satellites, numbers are keep increasing nowadays. Capacity is remaining there. That means now India also is embarking, like whatever happened I told, Artemis a few days back, a small setback, they have taken back the launch vehicle, they will come back. Similarly, few weeks back, I think our own small satellite launch vehicle also on test run, yes, last minute some failure was there. For final stage, some small issue was there, but that will be get corrected if coming weeks it come out. When that comes out, and versus another activity putting together, something else is going to happen there. So now you looking back here, the global space economy is a big number we are talking about. And that is broken into, as I told here, satellite, launch vehicle, launch service, and after launch what we can do. This under the 4 umbrellas, many things are happening there. People can chip in whichever the way it's possible. This just gives a glimpse of what we talk about the space global economy means what. Okay, not only everything is not satellite, everything is not launch vehicle. It is much beyond that. The service-based activities also is beyond there. So, but today ISRO is concerned. ISRO is spending more money in technology and other things, but application point of view, not much money is not being spent there. That's why the private industry is getting into that, into the space applications will play a major role, because really the thing is on space application. Actual economy you look at here, really the number is, launch vehicle is very small, satellite also small, but non-satellite and other activities only more. So there actually ISRO's strength is not there, but I think there we can chip in and definitely we can do a more. While doing it, I think another lesson learned is, until now across India we had various centers, and then one by one you bring, assemble and launch from Sriharikota. This was okay when we are launching for few satellites per year, but now we are talking about satellites to be numbers. When such a number is coming with respect to your logistic, with respect to transportation, with respect to your supply chain, very many aspects point of view, I think this will not work it out efficiently. Definitely it calls for another way of doing it, and that's what we are trying to tell about here. Okay, this is what I am trying to advocate. This is called, there are two space corridors, north and south, being talked about in India. And north corridor, I think strategically launch vehicle putting there, not possible. But south corridor, you look at here, even south corridor also, it's still centralized with the north of Tamil Nadu. Okay, south of Tamil Nadu is left out. Okay, but strategically south of Tamil Nadu is very, very apt for a new concept what we are talking about here. That means everything instead of all around India, southern portion of Tamil Nadu, you put everything together, keeping our Kulasegarapattinam as a launch site. It gives a very, very theoretically, a very good, scientifically, very good launch site. From here, we can, for the similar given launch vehicle, a bigger mass can be launched. Okay, and if you are able to centering around that place, if you are able to make all the logistics together, that means the launch vehicle, the satellite, everything put together, we are able to arrive at a space park. Whatever we are talking about for the defense corridor, similar thing like that, if you are able to do around that area, we have Mahendragiri, we have Kulasegarapattinam. These two connecting, you arrive at the new facilities. I told whatever I built in Bangalore, which can make simultaneously 20-30 satellites, bringing various things from Ahmedabad, something from Trivandrum, something from Hyderabad, something from Dehradun, something we are bringing and doing. But instead of that, everything clumping together, we are able to do with the lessons, whatever we learn, make another set of activities there. I think then it opens it up a big opportunity, wherein rolling it out almost every week. Why not even every week? Every day one launch is possible. Theoretically is possible. Because SSLV launch, every 24 hours one launch vehicle making is possible. That means every launch vehicle you should have at least 2 or 3 satellites can be loaded there. That means every launch is possible. That is Elon Musk's, not alone Elon Musk, multiple people together, we can make one big Elon Musk. Because Kulasegarapattinam gives a very, very advantageous position, which sometime back we left it, but today it's available with us. With things put together, I think if we make a system which will be an alternate. Now we are talking, people are looking for alternate from China. I think definitely people are looking for alternate to Elon Musk also. I think there is a place with us, it's sitting for us to do the operations. I think we are able to take things together with all the lessons learned up to now. Put the things together, I think we have the answer, we have the opportunity, we have the government backing us, we have the time with us, we have good number of countries which they are embarking into space today, and they are looking for the better solution. I think we will be able to go a lot more in this arena. That means, to summarize, you look at here, primary revenue earners remain satellite navigation, followed by communication systems and imaging systems. Not only is making satellite, not only launching, beyond that. But today, India also has its own NAVIC. Okay? Beyond GPS, beyond GLONASS, we have our own satellite, and that has been operationalized, and that is a huge potential for the user equipment. That is a huge potential we can do. And second generation of NAVIC also coming, And just to tell you, in the even the first generation Navik also, the last 2 or 3 satellites have been in private industry. That means private industry also has been given a hand holding and trained, and they are ready to make the satellites. I think second generation, full and full can be done by the private industry. I am very much confident on that. And beyond that, and as of now, we have launched 342 foreign satellites from 34 countries. Some more countries also entering. That means potential market also sitting there. And beyond that, India has trained, already trained 34 non-spacefaring nations, and this will continue. This process is happening, that will continue there. And beyond that, right away, the satellites which are launched by ISRO, which is already sitting as a space assets, and good number have been already being earmarked for private industry to take over. So that much of very, very positive thrust coming from government of India. I think there is very, very many things. It is like a hot cakes are available. Only people are required to take that, which slice you want to take it. I think that's what we are looking for. And globally, demand for small satellite reaches also keep growing. That means India's new space policy is giving ample opportunity for the private industry to be a part of India's development is concerned. So in this you look at here, because India has almost touched everything. Instead of only Indian has not gone to the space. There is only one thing. Other than that, everything we have done it. So that's, I think we have a good avenue can be part of this. Because putting a man into thing, it will be next step will happen ISRO. So once private industry takes for this, ISRO will take care of how putting Indian into a very safely into the space, bringing back safely back, and it can be more economical. Like whatever we have done Moon or Mars, I think that also will be done there. So that opens it up another. We talk about tourism to Costa Rica, tourism to the space or Moon also possible. Okay, that also from India is possible. Okay, I think we will be able to provide that. So you need not worry for the Costa Rica visa or US visa. With our own Indian passport, you can go and come back. I think that is very much possible. So that's the things for such R&D activities when ISRO is taking, these routine missions of doing this and making it the commerce is possible. So combining all the things, watch out for the big problems. That's what I initially enumerated. But I feel they may hide a big opportunities. Okay, that's what banana fiber also. It was something was hiding. So something was hiding in when we go for the Moon mission. Something was hiding when we go to the Mars mission. I think I expect something is much big is hiding beyond our Indian space program in the private industry is concerned. Thank you. Thank you very much for bringing up.
Any questions? Please put up your hand. That one.
Thank you, sir, for that very insightful presentation. And it is such an honor to hear from you also. Thank you very much on that. I have 2 questions. You mentioned about 30 satellites in 36 months. I mean, indeed a great feat. But you mentioned about the supply chain and also the infra that was set up to do that. But was there something else that was done, in terms of modularity, standardization, etc., which sort of speeded that process? That's question number 1.
Yeah.
The question number 2 is more on the growth that we are seeing in this space. Many satellites going into the space, growing exponentially. I mean, on a lighter sense, would there be a traffic jam in the space going forward? And if so, how do we handle the debris and waste? And, what would be a sustainable model towards that? Thank you.
Yeah, I think what you asked is the first question is, it's not only the infrastructure coming there, it's basically driven as I slightly dwelled into the banana industry now, taking from that to get how we have planned it out. Similarly, to make that to happen, okay, from 4 satellite, every 4 year one satellite to making every 4 week one satellite, just number is not possible. So definitely the sense of standardization is called for. That's what the lessons what we learned from Mars. Okay, actually originally mission Mangal, somebody would have seen that. Originally that mission was configured to go to the moon only as for Chandrayaan 2. But for various reasons I told earlier, we thought instead of waiting for a long time, we can make use of this. So that's why a mission which was originally planned for a moon has been reconfigured to go to the Mars. That's what I called grafting versus trying to make. This time we made it. When we made it, that gave an basically answer to us. It is possible to have standard packages. Actually, all the standard packages given to the industry. We have the telemetry package, solar cell generation, the wheels, gyros. These are all the standard packages we have put it, and that was coming from industry in numbers. So, within the infrastructure, whatever I built in Bangalore is basically collecting those things and integrating that. It is not fully making the crafting the satellite. It is that means it is instead of every satellite making the separate system, like your tires, like your wiper, like your exactly. Similarly, we standardize the systems there, and that goes into there. And majority of the things will be software reconfigurable. So specific to this mission, software reconfiguration is good enough, but whereas hardwares can be taken and configured. Exactly, that's what we have done, and that is a major thing. That is a major thing in which we have modified this concern. Then that's how we are confident. Now we have good number of basic private industries already doing these systems. And as I rightly told, last few of the navigation satellite done by the private industry. That means this integration also we are able to do. That means today end to end our industries can do. So that is the one government of India had confidence. Now they are trying to hand over that to happen. So that portion is that way. Coming back to the more and more satellites, yes. And once upon a time police was not there, but police came. Traffic police was not there. Traffic police came. Correct, na? Similarly, I told the 4 departments, making a satellite, making a launch vehicle, making a launch and application. Now one more is coming. That one more is basically you have to the traffic monitoring control. Okay. Nowadays, yes, on today, our control center either in a master control facility in Hassan, Karnataka, or in Bangalore was trying to look for our satellite, whether it is performing okay. Today, we made another control center. This will look for towards our satellite whether any other satellite is coming and hitting. You got the point, no? So that means we want to avoid any collisions to happen. So that's already started there. Now today, typically every month or every 1.5 months, at least one satellite or other not hitting. To avoid not to hit, we do maneuver it. Okay, because what happened? So many satellites are going, something got defunct, that you cannot control that. So now you have to realign our satellite to do that. One. Second thing is, even while launching the satellite also, we will be looking for various time. Never use Panchangam. Somewhere people don't know Panchanga. We will be looking for various objects. One such object is whether which out of any satellite cluster is coming. When launch, it should not go and hit that. So we will try to avoid that also. So the launching as well as monitoring, now we have another different group. Having done all these things, now the norm is, once the launch life is about to over, we are supposed to throw the satellite much above, something called graveyard, a satellite which is much above, or to put a burial ground. Okay, fire, burn it or bury it, like whatever we are doing for human being. Same thing is now, the satellites last few years, whichever the launch, it's have its own apportioned fuel. That fuel will either push it much beyond, so that for centuries it will not come, or else push it down. Okay, and beyond this, another thing is happening. Recently, one satellite has been launched. This will go and search for any one of in between satellites, na, which have been defunct, we cannot control. So to collect the garbage and throw it out. That's also happening there. So this another domain, it's keep coming.
Anybody else? Thank you then. Thank you.
Thank you.